Okay, so let's just go ahead and jump right in. In order to solve inequalities, we must use opposite operations. So h plus 4 is greater than 4. In order to solve that, I'm going to use opposite operations. So first you're going to put a box around your variable, that's the unknown, and we want to solve for the values of h that make this whole thing true. All right, so the opposite of adding 4 would be subtracting 4, and whatever you do to one side, you have to do to the other side. So now I have 4 subtract 4, that leaves me with h, and h is greater than 4 subtract 4, which is 0. So any value for h that's bigger than 0 will make this true. Okay, so on your graph, it's not numbered, so we can number it ourselves. I'm going to put 0 right there because I'm the one numbering it. And my solutions are any numbers that are greater than 0. So that'd be 1, 2, 3, and anything in between. Now the inequality symbol is a greater than symbol, and my arrow has to match that symbol. And so this is what the graph will look like. Since h is greater than 0, I have to have an open circle on the 0 because it cannot equal 0. It can only be greater than 0. Okay, let's go ahead and take a look at D. Go ahead and pause the video and try to solve it on your own first. Okay, if you didn't pause the video, make sure that you actually try it before looking at this part. You're only cheating yourself if you don't, because this is the last, some of the last practice that you're going to get before you take the exam. But it's the same idea right here. We're going to put a box around the variable. I forgot to mention this on part C, but the reason why you do that is because you're going to eliminate the constant number that is closer to the variable. So instead, like sometimes you're wondering, well, do I get rid of the 4 or do I get rid of the 6? Like, what do I do there? You want to get rid of the number that's closer to it, okay? All right, since 6 is closer to the variable, that's what we're going to eliminate. So we have, we're subtracting 6, so we're going to do opposite operations, and we're going to add 6 to both sides. All right, now the 6's eliminate each other, so we're left with x, and x is less than or equal to 4 plus 6, which is 10. All right, so now on your graph, since we're the ones making it, I'm just going to put 10 right there, right? And x is any value that is less than or equal to 10. So it could be 9, it could be 8, it could be 7. That looks really sloppy. Let me clean that up. All right, since my solution is x is less than or equal to 10, we're going to put our circle on 10. We're going to shade it in because it can also equal 10. And our arrow has to copy the inequality symbol, so that would be pointing in this direction, just like it is in our solution right there. And there it is. All right, let's take a look at, let's take a look at number 8. Whenever you have an inequality written in this way, it's going to be easier to graph it if you just rewrite it into an equivalent form. So negative 11 is greater than t plus 7. That means that t plus 7 is less than negative 11. It means the same thing, okay? Graphing is going to be easier. Okay, so let's go ahead and put a box. Actually, you know what? Go ahead and try and solve this. Pause the video. Again, you're really not going to get anything out of just copying it down. So let's try and solve it. Ready? Okay, I'm not going to be the police officer and chase you down, but if you didn't try it, at least try and, make sense out of this, all right? So we're going to put a box around the variable term, right? You're going to subtract your constants. You want to figure out the values for t. So we're going to do opposite operations. Okay? Now the 7 cancels out with negative 7, or when you subtract them. So t is less than negative 11 minus negative 7, which is going to give you negative 18. No, that is not a mistake. It is less than negative 18. Okay? All right, so now on our graph, since we are the ones numbering the graph however we want, we can put the negative 18 right here. And anything that is less than that, so like negative 19 would work. Negative 20 would work. This is getting kind of clustered. Put negative 17 right there, since I don't want to write any more on the other side. It's getting kind of messy. All right, now our solution is less than 18, so that means we're going to put a circle on negative 18, and we can't shade it in because it's just less than. And our arrow is going to copy the inequality arrow for less than, so that's why we copied it. Any number less than 18 will work for our solution. All right. Okay, give number 7 a try. I apologize for the order on these. I'm just taking screenshots from the online textbook for extra practice because it seemed that we were having trouble yesterday. Try number 7. Pause the video. All right, whether you tried it or not, I'm at least going to give you the solution to that to see if you got it right, okay? And there's more of these on the practice test packet. Here it is. All right, so there's the solution and the graph for number 7. All right, ladies and gentlemen, we really did not get to talk about the multiplication and division problems, and I will go over them more on Wednesday, I promise you that. But for now, at least let's get some practice together. For number 10, what this is saying right here is we're saying that 4 times the value of x is greater than or equal to 36. And we want to find the values for x that make that true. So in order to solve, we're going to use opposite operations, okay? So we're going to say, okay, instead of multiplying times 4, the opposite of that is dividing by 4. And whatever you do to one side, you have to do to the other. All right, so 4 divided by 4 is going to leave us with just x. 36 divided by 4 is going to leave us with just 9. And the symbol is going to stay the way that it is, okay? So for any values that are greater than or equal to 9, 4 times that amount is going to be bigger than or equal to 36. Like, think about it. Like, pick a number bigger than 9. 10, right? 4 times 10 is equal to 40. And 40 is definitely greater than or equal to 36. It's bigger than 36, right? If I was to replace 10 with the number 9, okay, let's say 4 times 9. Well, that just equals 36. And while 36 is not greater than itself, it's definitely equal to itself. So that would still be true, okay? All right, the way that we would graph it is you would just go ahead and you'd put a 36 right there. There's no labels on it, so you can label your number line however you want. And anything that is greater than or equal to 36 will make that true. So we got 37, 38, and so on. Gonna circle it. Color it in because it's or equal to. Oh my gosh, I already messed that up. Let me fix that. Okay, it's greater than or equal to 9. So I circled it on the 9, 10, 11, 12. And our inequality symbol tells us which direction that it's going to go. So it copies that symbol, and it's anything bigger than or equal to 9. Okay? All right. Let's take a look at number 11. Already I can see this. I need to rewrite it because our graphing is going to be easier. If 20 is less than 5 times t, then 5 times t has to be greater than 20. It means the same thing. Now we're going to use opposite operations in order to figure out the values for t that make this statement true. Okay, the opposite of multiplying times 5 is dividing by 5. Whatever I do to one side, I have to do to the other. So 5 divided by 5 leaves me with just t. And then 20 divided by 5 leaves me with 4. So t is greater than 4 is my solution. Okay? And when you graph it, you know what, let me clean this up. Yeah, that wasn't much better, but it is a little bit better. Okay, so right there, 4, 5, 6, and so on. T has to be greater than 4. So I'm going to put a circle on there. It's not going to be open, or it's not going to be colored in because it has to be bigger than 4, but it cannot be 4. Now I look at my inequality symbol, it's pointing to the right, and so the graph has to copy that. So anything to the right of 4. It could be 4.5, it could be 4.001, but anything greater than 4 will make that statement true. Okay, now let's go ahead and take a look at numbers 12 and 13. What this says is we're saying something divided by -6 is greater than -16. And in order to solve, we have to use opposite operations, okay? All right, so the opposite of dividing by -6 is to multiply by -6, okay? Let me finish writing that down. All right, so I'm going to multiply times -6 so I can cancel that out, but whatever I do to one side, I have to do to the other. So I'm going to multiply this times -6. Okay, now -6 is going to cancel out with the other -6. So that leaves me with just s. On the other side, I have -6 times -16. Okay, now in this situation, we have s on one side left over, and then we have 6 times 16 is 96, and a negative times a negative makes it a positive 96, okay? If we were to keep this symbol as greater than, like let's say that s was bigger than 96. Let's say, give me a number, 97, right? 97 divided by 6, by negative 6, is going to equal, it's going to equal negative 16.16 repeating. And that's actually smaller than negative 16. We need it to be bigger than negative 16. So that's why we can't have numbers that are greater than 96. So we're definitely going to talk about this a lot more, but I at least wanted to expose you to it. Whenever you multiply or divide by a negative number, you have to flip the inequality symbol. So let's go back and do that. Okay, pick a value that is less than 96 this time, like 95 or something. That's close, but it's still smaller than that. If I have 95 divided by negative 6, that's going to equal, negative 15.83 repeating. And with negatives, remember, the closer it is to 0 of its negative, it's bigger than the number that is negative that's farther away from 0. So that is a true statement. So S has to be less than 96. That's why we have to flip the inequality symbol whenever we divide by a negative. Okay, that was a long-winded explanation. We're going to practice that more when I get back. But just so you can see how it works, if I have x divided by 4, negative 4, that's greater than or equal to 8, okay? To solve, the opposite of dividing by negative 4 is multiplying by negative 4. So whatever you do to one side, you're going to do to the other. Okay, so 8 times negative 4 is going to be negative 32. Because we multiply by a negative, the same rule applies, so we have to flip the inequality symbol. And then that's going to give us x has to be less than or equal to negative 32. Don't worry about the graphs of these for right now. This is just to expose you to it. All right, you have the rest of the period to work on your practice quiz. Let's get her done.